G'day, welcome back to the third part of the third lesson of part two. Oh, hate the naming, whatever. In this one here, guys, we're going to look at the last two diagrams just to make your brain a little bit less mushy because I figured 6 diagrams in one video would just be horrible. So let's have a look at today at the data dictionary and then the structure chart. The data dictionary is going to be quite quick, and then the structure chart will take our time with that one. He's not hard, but he just takes his time to sort of get the concept. So a data dictionary is a comprehensive list of all the important variables that you're going to use to store your data in your system. Okay? These aren't things like I and temp and input. These are more things like food item name, food item price, food item description, food item picture name, all those kind of things that are really important to the fundamentals of the program. And the purpose of using the data dictionary is that we have multiple developers working on the app at the same time. We want every single one to be on the same page in terms for the naming of things, the data type we're going to use, and the validation, and a couple of other things that we'll look at. Because, for example, imagine I made the Canteen app, and in my portion of the application for the menu, all of my prices I'm going to use single floating point numbers. And then in another portion of the app, another developer uses double floating point numbers. Well, there is a difference. There is a memory usage difference and there is a precision or accuracy difference between those two variables. And things might actually go a little bit wrong. They might be compatible. In fact, what would be worse is if someone used integers, because then there would be no fractional portions and you couldn't have cents on your prices. But that's a better example. They are compatible, but we lose data in one portion of our app. So what do we need in our data dictionary? We need a name, a data type, a description, an example, and then any validation that applies to those variables. In other words, what values can it have, what it cannot have. So here is an example data dictionary for you. This one is essentially for a business keeping track of their employees. So for this one, we have got 1, 2, 3, 4, 5, 6, 7 variables in our data dictionary. For each, we've got a name, we've got a data type, a description, an example, and validation rules that apply. So the name of this variable here is user ID. You can see it's got a capital U and a capital I, and all developers would have to make sure that they've done that in their app as well. We're going to use strings, and the description is it's a primary key uniquely identifying a user. The first 2 letters must be of the surname, followed by a 3-digit identifier such as PT, so first and last letters, yes, and then 3 digits. And then the validation is we must have letters at the start and it must have 3 digits at the end. The username is going to be a string. It's the username of the employee, such as Kim. First letter must be a capital letter. Okay, and the same thing for date of birth, times late, pay rate, floating point as you can see, which has to be greater than 20, less than 400. Social club is a Boolean, so yes and no, example no. Validation, we don't include one because Booleans are so simple in their nature. And departments, array of string, in other words, a list of strings, the names of the departments, and etc., etc. Okay, so that's a data dictionary. There's a quick example for you there. As a bit of a test to yourself for the Canteen app, I want you to come up with a data dictionary which includes the name of the food item, a price for a food item, description, and a picture name, that is. Okay, so come up with the data dictionary. You should have your 5 columns, the variable, data type, description, example, validation, and then the 4 variables with their type, their description, an example, and the validation. Okay, good luck. I'm not going to do this one because I want to focus on this guy. So pause if you need to, and then come back. So the last diagram that you need to learn in this part of the course for now, I lied because there's another diagram we're going to do next, but it's a whole thing of its own, is the structure chart. The structure chart shows you the functions or like the modules of your code and how they're connected together and how data is passed to and from each function of code. So let me quickly show you an example. We have got rectangles. We have got arrows that show direction of data flow, and they've either got a colored in circle or an open circle. And then we have got 2 other little symbols, the triangle on a line or between lines, or this little repetition arrow. So quickly, let's go through these symbols. The rectangles, which I don't have listed here, are the functions of your program. The lines show the connections, and these arrows show the direction in which data is passed between those functions, and we call those parameters. Now, these open-ended circles are any data type: strings, integers, not booleans, strings, integers, floats, arrays, all that kind of stuff. The filled-in circle are what you call flag parameters. In other words, a boolean. Okay, so you can literally write on the side here, boolean, and on the side of this one, every other data type, because that's what they are. The next one, the diamond indicates a decision. So if you've got two paths like this and there's a diamond in between, that means you can choose to go this way or you can choose to go that way. If there is a diamond on the line, so it's not in the middle, but it's on the line, that means that particular line you can go down, but you do not have to. So we'll talk about that in a second. And the last one, repetition, appears on the lines, and that just means you can call those functions as many times as you like. So let's have a look at my little example for our Spotify thing again. The way you read a structure chart is top, down, left to right. What I mean by that is you start at the home up here. It's an upside down tree of sorts. We start at home and we first go down to the left. So we go down to the search function here. And on the way, we pass it our search terms. Okay? So down here we search, and we're sending it the search terms. And then the search does all of its lovely work. And then we're gonna, if we have any other lines coming out the bottom, we keep going down and to the left again. So the search function will pass the results of our search down to this function, which will produce the results for the user. And because we're done, we go back to search, and we're done here, so we go back to home. Then home now has to go down to the right by default. Chosen song gets sent to the play function, and it plays your song. So this is the basic flow of a structured chart. You always go down left. When you're finished, you go back up. But if you're not finished, you go back down, and then you go up and down to the right. And then you sort of zigzag all your way. It's like sailing. You never sail in a straight line. You always sail left and right. Okay. This one is a much more complicated structured chart that you can use as an example. Have a look at it. I'm going to just go through it very quickly because we're almost out of time, or at least I want to finish up very soon. But if you have a look, we start up here in the school library system, and we now have these two crazy symbols. First of all, we can choose to go left or choose to go right, and we can choose to do this as many times as we want until the library closes. So let's go down to the left and borrow a book. The first thing we have to do is go down to validate student information, and on the way back, we send a boolean or a flag that tells us if that information was valid back to here. Now, we can go back down this way. It's an optional and it's oh, I forgot the student ID. Sorry, I missed that one. That goes up from here as well. We can now process books optionally and as many times until we have no more books. The first thing we do is we get the book info. What's the book ID? And is the book available? And then optionally, we update the book in the student's files by passing it the ID of both. And when we're done, we go back to here and we go back to borrowing, and then we go back to the library system. Then we're going to head down to the returning, down to check book, which goes down to locate book record, which gets the book details and the due date, which goes back to here, which then sends the due date down to check if it's overdue. And then we send back if it is or not overdue. And all those things, the details and if it's overdue or not, go back to returning. We update the files for the book details. We send back the student details. And optionally, we produce a report with the overdue flag, the student details, and the book details. So it's a bit of a crazy assortment, but it shows you the flow of the data in our code now, and it shows you the order of operation for all those various things. So, to bring it to a close, I would like you to produce a data dictionary for our Canteen app and a structure chart for our Canteen app in terms of the kids being able to browse through our menu, add things to a shopping cart, and purchase them. See how you go with that one. Thank you very much for watching, guys. We're done with the design section-ish. In the next video, we're going to deal with algorithms, which is a big topic of its own. So we're going to split that up into lots. So I'll see you then.